Welcome to this Newmero instruction video. Thank you for taking time to watch it. We hope this video will help you and the children around you get the best out of the bricks. This video consists of 3 parts. The first part is about the design of the bricks. The second part is about the exercises and games you can play with the children. Finally, in part 3, we give you an easy to remember summary of the benefits you can get by using these bricks. Now, let's start with part number 1, the design of the bricks. The main elements of the Joy of Numbers consist of bricks and a bag. Let's take a closer look. The yellow bricks, or the units, are these bricks. They are numbered 1, 2, 3 and so forth. The next set of bricks are the green ones, the tens. They are numbered 10, 20, 30 and so forth. Then we have the hundreds, the blue bricks, and finally we have the thousands, the orange bricks. We also have a nice cotton bag into which you can store the bricks or use it for some of the games, as you will see shortly. Now let's take a look at the design features. So let's take a brick, let's say number 3. The first thing you notice is this knob. We call it the connector knob. It is used to keep bricks in place so we can stack them one on top of each other. Next, you see the digits or the number symbol, in this case 3. If you look at the top edge, you will notice some small knobs. We call these the counting knobs. So there will be 1, 2, and 3 corresponding to the value 3. Now if you look at the left side, you will see a jigsaw pattern, and similarly on the right side you will also see a jigsaw pattern. If we flip the brick around, you will see a hole. It's called the hole for the connector knob. And that's it. Essentially there's no more to it. Now let's take a look on how we can be using these design features. So let's start with the connector knob. We take brick number 3 and let's take one more brick, number 5. So we will use the connector knob to place one brick on top of each other, and this is called superposition. So placing them on top, one on top of the other. Superposition. Let's take one more brick. And we now have 3 bricks. Now, the next way we can stack bricks is in what we call opposition. So instead of putting one on top of each other, we put them back against back. This is called opposition. So we flip them, back against back. Let's see, 5 on the 3. And this is called opposition. Now the next position we are going to attempt is called juxtaposition. Let's take 2 bricks, 2 and 8, and let's try to match the edges. So as you'll see, the jigsaw patterns actually match perfectly here. So this position, one next to each other, is called juxtaposition. We can take any other brick, like number 6, and you'll notice that we can attempt to push them together, but they don't match. So this is called juxtaposition. The final position we're looking at is called top edge against top, or just top against top. Let's take number 3 and 5 and flip them, top edge against top edge. You can also put the bricks on the table and simply flip it, top against top. And you can take any other brick, like number 9, and try to attempt to put it top against top. Now to part 2 of this instruction video, exercises and games. We have 3 major groups of exercise and games in this part. The first group is about getting the basics right. So this is about recognizing a digit, its name, its value and so forth. The second group of exercises is about understanding the relativeness of numbers. So why is something bigger than something else? Starting to be able to sort and sequence numbers. Finally, the third group is about composing decimal numbers, so building and decomposing numbers. So for instance, 23 would be a 20 plus a 3, and this would be a precursor to several exercises where we gradually train addition and subtraction. We build self-confidence, and there are also some interesting exercises about cooperative learning where we can have peer-to-peer training. So let's get started with the next exercise called Who is this? This exercise is called Who is this? And we'll be using the yellow bricks. So let's take these and spread them out on the table. Now, what you will do is pick any brick, for instance this one, number 3, and you will show it to the child and ask, who is this? And the child should ideally answer 3. And you can take any brick like this one and ask, who is this? The answer would be 7. Now continue in this way, and if you take for instance this brick, what is actually happening is that the child starts associating this image or symbol, which is digit 4, with the sound or the name of 4. So this is an association between a representation, a symbol, and the name or the sound of that digit. This exercise is called Find a Fish, and it is the reverse exercise of Who is this? So what we do is we are using the yellow bricks, and we will be spreading them on the table. And now, instead of picking out a brick and ask, who is this? We will actually do the reverse, so let's mix them. And now we'll ask, can you find number 4? So where is 4? The child will be looking and perhaps pick this one up. That's not quite right, so let's try again. Where's number 4? And eventually the child may pick the right brick. Well done. Let's put that one aside. And we continue like this. So let's see, where can we find, where is number 2? So the child will be looking and eventually may pick up this one, which is indeed number 2. So in this exercise, we've essentially linked the name to a symbol. In the previous exercise, we did the reverse. So in total, we have now interlinked the symbol to its name. Let's move on to the next exercise, where we link it to the value. This exercise is called Counting the Knobs. We will be using the yellow bricks. Only this time we flip them. So put the face down or the backside up. And now we'll be asking, let's mix them. And now we'll be asking the child to find a specific brick. So let's say we say, please find number 2. So the child cannot really find number 2 except looking at these counting knobs, because all the bricks are identical when facing downwards. So let's say the child picks this one. The child would have to pick this one and count the 2 knobs. 1, 2. Let's see. And indeed, that is number 2. So let's continue this way. We could ask, where is number 4? And the child will start looking. And eventually may find this one. Let's see. Start counting the knobs. 1, 2, 3, 4. And indeed, it is number 4. So in this exercise, what we did was we associated the value to a symbol. So we mentioned the name of a brick, 2, and the child had to find the corresponding value, the 2 counting knobs. Now, if we recall the 2 previous exercises, what we've done now is combining 3 things. First of all, the symbol or the digit is associated to its name or the sound. And finally, we associate that to the value. So combining these 3 things, we have the basics in place. Now let's move on to the next exercises. This exercise is called Who is largest? This is about understanding what is small and what is large. So starting to understand the relativeness amongst values. being able to start sequencing and sorting numbers. So let's start with the yellow bricks. You will spread these on the table. Now ask the child to pick any value, any bricks. So let's say the child picks number 3, and you will pick another value. Let's say you take a brick number 5. So now the question is, we want the child to understand that something is bigger or smaller than something else. So we have these 2 bricks. How do we figure out which one is largest? Well, this is where the design of the brick comes in. Now recall that we had the notion of superposition. So if the child doesn't know which one is largest, it can actually start to superimpose the 2 bricks. The design of the bricks will guide the child to the correct answer, so the child can figure it out itself. So let's try to superimpose them here. So once they're superimposed, we can now look at the counting knobs. So over here we see there's clearly more on this side than on that side. So it seems that this brick number 5 is bigger than number 3. So you won, you had number 5, let's put them aside. Now ask the child to take one more brick. So let's say the child takes number 6, and this time you take number 4. If the child doesn't immediately know which one is largest, again repeat the same exercise, stack them in superposition, and the bricks will tell the child, will guide the child to the answer. So let's see, okay, it seems that we have more over here. So brick number 6 wins. This time it's the child that wins. So you can continue like this and perhaps add both sets of yellow bricks. Have fun. This exercise is called How Much Larger, and is actually a follow-up exercise on the previous called Who is Largest. So essentially this one goes like the previous one. So you ask the child to pick any brick. So remember to mix the bricks. So let's say the child picks number 6 and you pick number 3. So the child will now say, my brick is larger than yours. 6 is larger than 3, because the bricks will tell. Now what you will do here is you'll say yes, but how much larger? So again, the bricks will guide the child. So if we start looking at the counting knobs, you see that there are 3 more counting knobs here. So this brick number 6 is 3 larger than the other brick 3. So essentially what is going on here is that the child starts understanding not only is 6 bigger than 3, but the difference is 3. So let's see what happens now. Let's take one more set of bricks. So let's say you took 5 and the child took 2. Again, who is largest and by how much? Well, 5 is clearly larger, but by how much? Let's look. Again, take a look at the counting knobs that are sticking out. We have 3 more here. So the child will be able to say 5 is 3 bigger than 2. This exercise is called sorting the numbers. And in this exercise we'll start training sorting the numbers either in increasing or in decreasing order. So what we'll do is we'll start by using the yellow bricks and ask the child to pick any 3 numbers and put the rest aside. So let's say the child picked 9, 6 and 3, and now we need to get those sorted. So assume the child sorts them like this. So 3, 9 and 6. Now are these sorted? How will the child know? Well, again the bricks will tell it. So let's try to stack the numbers and see what it looks like. As you can see, it looks like a mountain. There's a peak. So this is not correct. It goes up and down. Now, if the numbers had been sorted correctly, so in this case 3, 6 and 9 in increasing order, again stack the numbers. Let's see what the bricks tell the child. Here you will see a staircase that goes up, so this way it is sorted correctly. We have a staircase. Now let's say we had sorted them in decreasing order, so 9, 6 and 3. Again, so we see it goes decreasing. Let's see if they are sorted correctly. Let's stack them. Again, we have a staircase, only this time it goes down. So the numbers are sorted if we have a nice staircase. Let's let's see if we sort it the other way. This time it's not correct. Again, here we don't have a staircase. In this case we have a valley, so we have a dip, and that is because the numbers are not sorted. Let's try another sequence, 6, 9, 3. Let's see if we stack them. What do we get again? Again, we don't get a staircase, we get a mountain, and then we know that they are not sorted. So what you can do now is that you can also start considering a bigger sorting exercise. So let's perhaps throw more bricks in. Let's take 4 in, and again you can mix them. The child can then start sorting them, attempting. Let's say it arrives at this one, so let's stack them. And indeed, let's see, here we get a nice staircase. So we know that these 4 numbers are sorted in the correct order. This exercise is called Inbetween, and is actually also a sorting exercise. So what you'll be doing is taking some bricks, pick 2, any 2 at random, and put them apart in ordered sequence. So let's say we picked number 3 and number 7. And now what you'll be asking the child to do is find any brick or value that sits in between number 3 and number 7. So a correct answer could be anything between 4, 5 and 6. So let's assume the child picks number 6. It sits in here, let's see. So here we have a sequence of 3, 6 and 7. And these are correct. These are sorted correctly because we can again stack them and see we have a staircase. Now we can essentially expand this exercise, so let's pull the bricks a little bit apart and we can ask, can you find a value or a brick between 3 and 6? And let's say the child picks number 4. Again, you can see that these are correctly sorted by stacking them. This exercise is called Add the Cash Counter. You'll be needing the bricks that correspond to the coins and the notes. For instance, this could be a €5 coin. We could have a 2, the brick number 2 corresponds to €2, 10 for the €10, and 100 for the €100, and so forth. You will also be needing some toys that you could sell at the cash counter. So here a mouse, and let's say we take an elephant. Now you'll have to play the roles. So one will be playing the customer who comes into the shop, who has all the money, and the other one will be the merchant who will be selling the mouse and the elephant. So let's assume you start by being interested in buying the mouse, and let's say the mouse would be an easy price. So that could be 20. So you'll be giving this brick. But we could also try something slightly more interesting. Let's say it could be 21. So we would be building 21 and it would be swapping. So we've bought the mouse for 21. Next, let's look at the elephant. We could take the elephant and that could be a €55. So we'd be taking a 50 and a 5. We could also perhaps say something more interesting. It would be €49. So let's say the elephant now is 49. I don't have a 49. So as a customer, I'll be paying 50. And then I would need to get €1 back. So this is what I get back, and the elephant is mine now. So now you can continue the game and make it perhaps more interesting. Consider some other amounts rather than easy amounts. So perhaps forcing that 20 gets broken. So if the price is 18, you can perhaps also add some more bricks. And you can also consider swapping roles. So the child could be the customer who buys, and you can become the merchant who sells. Enjoy. This exercise is called 10 friends, and we'll be using the yellow bricks. So let's start by spreading them on the table. And what you will be telling the child now is that every brick has a special friend, a so-called 10 friend. So let's take a brick number 4. 4 has a special friend, it's 10 friend. That brick is number 6, because 4 plus 6 gives 10. This is a very important notion in the decimal system, and we'll be using this in some of the later exercises. So let's see, how does the brick guide the child? So let's take number 4 and number 6 and try to put them together using the juxtaposition. Let's see how this works. So we push the edges once against the other, and you will see there's a perfect match. And the match is actually on both sides, because 6 is of course also 10 friends with 4 and vice versa. So these bricks, the bricks actually show that it matches. Let's take somebody else. 5 is not a 10 friend, and you will see there's not a perfect match. There is a hole. And if we check from the other side, you will see they don't even fit in. But if 5 is not the friend, who is then? How would we know? Let's see. Let's take number 8. The bricks can also help the child find the 10 friend. Let's swap them back against back. And here you see that 8, there's an overlap. So 8 is too big. 8 is not the friend because 8 is too big. Let's take somebody smaller. Let's take number 5. Again, back against back, we can see 5 is not the 10 friend because something is missing. So 5 is too small. 8 was too big and 5 was too small. So let's take a value in between, and surprise, number 6 matches. And we can see the match actually both by putting it side by side or back against back. We have no overlap. This exercise is called building houses, and it is essentially about building multi-digit numbers in the decimal system. So you'll be needing some yellow bricks. You'll also be needing some green bricks. That could be 10 or 20, and we could perhaps add some more bricks, but let's start with that. So assuming that we ask the child, could you build number 15? So the child will have to decode this. It will have to take a 10 and a 5, and using the connector knob, stack them on top of each other, building a house or staircase. So this is 15. Let's say we then said, what about 23? Could you build 23? So pick the 20, decode that, and decode that 23 is a 20 plus a 3. So physically building number, you can compose it as a 20. You can actually decompose it. So you can touch the number now. 23 is a 20 and a 3. So implicitly building it, an addition is happening. Of course, you can also start adding more numbers, so we can throw in the 100 and ask to build 128 as 100, a 20 and a 8, and you can start adding more bricks. Enjoy! This exercise is called building an animal, and you'll be using the yellow bricks and the green bricks. So let's start spreading them out. And now you could ask the child to build an animal, and it could be a horse. So let's say the child starts by building an animal. The horse. And there you go, a nice horse. So now what is the weight of the animal? Let's see. We can start by taking the leg, which is 1, and then we'll be picking a 9, because those are 10 friends, so it's an easy add. That's 10 plus 5, we're up at 15, plus 6, 21, plus 15, 50, 71 total. And now finally 60, which brings us at 131. So that was the weight of our animal. Enjoy! Let's summarize the benefits of these bricks. They have been designed to make it fun and manageable for parents and adults to give the children the experience of the joy of numbers, to improve their numeric skills through games and exercises. It is about turning the abstract decimal number system into a physical playing and learning experience where we appeal to the tactile nature of young children. So basically, as you've seen, it's understanding numbers by touching them, building them, and decomposing them. We have a novel design guidance which allows children to figure things out themselves and support peer-to-peer cooperative learning between children at different numeracy levels.